Everyone should make use of a calculator. Take down the problem. The cumulative distribution function for the random variable x is fx of x equals to 1 minus exponential to the minus x squared by 4. Condition is x is greater than or equals to 0 and it is 0 otherwise. Then evaluate a probability between the range 1.1 to 2.11. Note that capital F is given so that it is a cumulative distribution function. In the statement, it is already given. A CDF for the random variable x is this one. If a CDF is given, then evaluate the probability between the range 1.1 to 2.11. Meaning of this is, I will explain. It is an exponential function here. Here it is exponential function. E to the power minus x square by 4. It is nothing but a second example. Exponential random variable it is. It is not a normalized Gaussian random variable, but here it is exponential random variable in which they have given fx of x and they have asked us to calculate here x is varying a probability in this range, means 1.1 to something 2.1. They have asked what is the probability in this range. If they have asked the probability between 0 to infinity, then obviously it is 1, because we have seen it already. The probability under the curve is always 1, but they have not asked the complete probability of the curve. Instead, in this range they have asked the probability. So this is what the meaning of that question. It is not a Gaussian and it is not a normally distributed random variable. It is exponentially distributed random variable. I hope you have understood the question now. So the probability should be calculated in this range, 1.1 to 2.11. All right. So we know that this is a lowercase f, so that PDF it is. A PDF can be obtained by differentiating the CDF. It is a standard definition. All right. What is given? CDF is given, and it is this expression if x is greater than or equals to 0. Yes, otherwise it is 0. Now, let us differentiate this given CDF so that we will get a PDF. Let us differentiate this. What is differentiation of 1? What is differentiation of 1? All right. Now a differentiation of this one. Sure. So it has two parts. It has two parts. So that differentiation of 1 minus is kept as it is, and the differentiation of exponential term. All right. Fine. Now, what is differentiation of constant? Differentiation of constant is 0. That is written here. Now, minus n is kept as it is. What is a differentiation of e to the power x? It is what? E to the power x. Or else, let us consider what is the differentiation of e to the power ax. A into e to the power x. All right. So in the place of a, what is there? In the place of a, minus should be written as it is, and e to the power x square by 4. All right. Then I square by 4 should be differentiated. 1 by 4 is a constant, should be written as it is. What is the differentiation of x square? It is 2x. Then 2 ones are 2 twos are. Simplify this. Minus into minus, it is what? Plus e to the power minus s square is written, 4 is written as it is. 2 ones are 2 twos are x by 2. Okay. So from the given CDF, we have calculated the PDF here. Right. Now we know this formula. I think You might have forgotten it already, but do not worry, we will remember it once again. That's yesterday's class. So this was explained. If the probability between the two variable, if the probability between the two limits are given, then what could be the formula? So integration over x2 to x1 PDF of a given number. It is the fourth property of a probability density functions. It was discussed in the last class. It was discussed, and I have said it is one of the important property as examination as the problem point of view. I quoted in the last class, so that's we are using here. The probability they have asked between the range x1 to x2. If this is the case, means this will be the formula x2 to x1 fx of x into dx. We don't know PDF, we don't know small f. Instead we know a capital F. Capital F is given here, but in formula a small f is needed. A small f is needed, so that we know the relationship between capital F and the small f. It is a PDF, a differentiation of CDF, that gives the a PDF. All right, so that for that reason we have calculated the a probability density function. Fine. Okay, now the question is, they have asked us to calculate the probability between 1.1 to 2.11. All right, that is nothing but a CDF. Apply the formula here. x2 to x1 fx of x. Fx of x is replaced here and limits are added 1.1 to 2.11. In the place of fx of x, it is written here. All right, but this integration cannot be carried. We need to go for a substitution method. In that, I will put a z is equals to x square by 4. This integration cannot be done directly, so that we will go for the substitution method. I will substituting z equals to x square by 4. Then limit will change. When x is equals to 1.11, then what would be the value of z? Replace or put x equals to 1.1 whole square divided by 4. Then do simplify it, we will get 0.3025. Everyone should make use of a calculator and cross verify the result. Here, why we are going for the substitution method? This integration cannot be solved directly. For that reason, I am simplifying the integration by substituting z is equals to x square by 4. That is written here. The other variable, then obviously limit will change. So that if x is equals to 1.1, then what will be the value of z? It is 0.3025. Fine. Then what is the value of z when x equals to 2.1? 2.11 square divided by 4. Then as a result we will get z is equals to 1.1130. Fine. Now this dx should be replaced in terms of dz, so that differentiate it. Differentiation of z dz, 1 by 4 is a constant. Differentiation of x square is 2x and dx. All right, then what is dx? Dx equals to, or else dz equals to 2 ones are 2 twos are x by 2 into dx. Do you find x by 2 into dx in this equation? X by 2 into dx, that can be replaced as here the z. So therefore this complete expression becomes limits are changed here. It is from 0.3025 to 1.1130, and e to the power minus z, and x by 2 into dx is replaced by z here. What is integration of e to the power minus x? It is what? Minus into e to the power x minus x, and limits are here, upper limit minus lower limit. First substitute e to the power minus 1.11 minus e to the power minus 0.3, and everything should be multiplied with a minus sign. Then we will get as the result 0.4069. Everyone should make use of a calculator and cross verify the results. For this problem, we have calculated the probability between the range 1.1 to 2.11. We are getting the result as 0.4069. So try this one. A CDF for the random variable x is given. Then evaluate the probability in between 2.5 to 6.2. Take a screenshot of it, try yourself and send me your answers in WhatsApp. Instead of x, here the variable y is used. In the previous problem, we have used x as a variable, but here we are using y as a variable, not an issue here.